All right. Now, it's kind of hard to tell if you can hear me. Oh, wait, no, it does tell me at the bottom. Okay, so hello, this is Sean for the people who are watching from a video. And I'm presenting on how to create a Haskell project using Cabal. It's actually pretty simple. You might find it pretty familiar if you're used to maybe Bundler from Ruby, or if you like, well, just about every language has their own anymore. And let's see. So I wanted to pick something that's actually worth doing. There's a problem I've been attacking recently on frequent pattern trees, or FP trees. And this doesn't really go through the whole concept, but it does give you enough to chew on and think about. Okay? So in this case, we're creating a frequent set tree, an FP tree, and we're trying to find some association rules. We actually don't go that far, because that would take like 38 slides. Yeah. So instead, we're just going to create an FP tree and show how to insert into it and display it. Okay? And we'll use this in order to find out how to write a project in Cabal. All right? So the general overview, you have to know what it is you're trying to write before you start it. It's a trie, a map, and overlaid linked lists. Okay? So the trie is just trying to compress the tuples, or in this case, they're actually unordered sets. So that way, if you have many sets with the same objects, you can use the most popular object as a prefix, and then that way you won't end up replicating it so many times. And the map is used in the first pass to determine which ones are the most likely objects or items in your sets. That way you can move them to the top of the tree, or try, if you prefer. And then the linked lists are actually, they're an aid to the query later on, so that you can, for example, find all of the sets containing A. Now, that is still necessary, but we don't go that far. All right?
So, okay, sorry. Do you have a trie for, like, how many tries are there?
There's just one trie.
Just one?
Yes. Okay, so the concept here is that when you query the trie, you should be able to tell it ACD, and it will give you how many times it's seen that set in any permutation.
Okay. So like, and that means like with all the other sets, right?
Yeah.
Okay, so we have like ACD, and then like all the other sets, and the value is like how many times this occurs in.
Yeah, for all of the other sets. Yeah, for every set. Okay. All right. The map is pretty simple, takes up a lot less space. It's just for each item, count how many times it appears at all. And then the linked lists are actually probably the most complicated part of it, and I have a hard time examining exactly how to make that functional, so I'm leaving that alone for right now. Let's move on to the next one. Okay, so getting started. The whole concept here I'm trying to walk through is like, sing along. In this case, we're programming along. And so probably the first thing to do is to set up a GitHub repo, or you don't necessarily have to do this, but if you're planning on putting this on GitHub, it's better to start out with the repo and clone rather than make the repo and figure out how to reset your upstream. Okay, so if you're going to do that, you can do it now. And then from here, you go into wherever your new repo is, and Cabal init. Or actually, you can even CD to FP tree or whatever you call your project, and then just do Cabal init without the argument.
Yeah, there's questions.
Oh yeah, yeah. Well, I mean that's the whole point.
So can I just do brew install Cabal?
Probably, but I don't have a Mac, so I don't know.
No Cabal.
Do you have Haskell platform?
Yes.
It should be part of that, I think.
All right. Let me try. Try.
Okay, I was hoping to get some feedback from the Hangout. I can't tell if you actually see it.
Okay, so the output of this is just like that, like Cabal file.
Yeah, it generates the new Cabal file. Okay. So if you have any questions, it says to ask your audience. Well, if you have any questions, you should see Q&A on the left, and you can feel free to type in anything you're concerned about, might have an issue with, because that's what we're working on. We're installing Cabal right now so that you can do Cabal Cabal init.
You want to share anything?
Okay, I'm just actually creating a file right now. I don't know if I should.
Yeah, so I just Cabal in it, and then it basically just asks you package name, version, license, you know, stuff about you, whether you're doing library or an executable, include documentation.
Okay, hold on. Now I will show you what this looks like on Kate.
This is just what happens here.
Oh, I forgot. Screen share makes you choose. Now you can see Kate. Okay, cool. So now, these are my notes. This is the FP tree Cabal we're trying to create. And in order to create it, I'm going to move over. Actually, I'll move it. All right, now I'll close these. And we'll create a Cabal project here. Let's make it a little bit larger so you can see. And I'll move it to a different screen. Okay.
We're building a library.
Yes, we're building a library. Okay, so do Cabal install here, or Cabal init actually.
Are we doing an Haskell 2010?
Yes. Okay, so we've got FP tree 0100. This is just a default first version. Apparently, the most popular license among Haskell users is BSD3. So that's probably what I would pick. That way you have a better chance of people using it without getting in problems. Okay? Name and email it can guess. The project homepage URL, in this case, it doesn't exist yet, but I can make up one.
And I can change it later, right? It's just a matter of Cabal actually just initializing stuff.
Yeah, it's just filling out the configuration file for you to begin. Okay? Okay. Now, this is the part I'm not really sure about. I think I'd probably call it data. Oops. Cancel. F5, not F5. Okay. And it's a library. I personally would see what exactly they look like to begin with. Source is generally the location you should keep your files and your source files. It'll just make more sense. I'm not really sure why they have none as the default here.
I actually didn't even get asked that question, but I said no to the documentation. So.
Wow. You're really roughing it now, right? Okay. Yeah, who needs documentation? It just gets in the way. Okay, so now we're in Haskell, and this is what our new Cabal should look like. Yeah, fptree.cabal. Okay, can you see that? That's kind of small. There. All right. Now you can see how it filled in like home page, license. These are pretty easy. But the one that we'll come back to a little bit later is build depends here. Base 4.6 and 4.7 is what it fills in by default. But we'll probably, well, not probably, we'll definitely be adding in a couple more as we move on. Okay? Now, let's see if I can have it move to the next screen. The entire screen would be kind of crazy. Here we go. All right. Wow, I never can get which side the screen is on. It's on the left, no, it's on the right, it's above. Okay, so we first, you might have to Cabal install, which is updating itself. But if you already have the newest one, then there's no sense in that. And you can start up your sandbox. And you use the sandbox here in order to manage the dependencies that you'll need for your library. That way, when you're starting from a sandbox, you can be guaranteed that you didn't accidentally include things from other places and forget to add them as a dependency. It also makes it easier if later on you find out that you don't need it, you can remove it by just cutting out the whole sandbox and starting over. Okay?
Do you have to update it before you do the sandbox? Because
No,
I
you
think
don't.
it's running right now.
It's optional. You can do that or not. But I don't recommend stopping it if it already started.
Mm-hmm.
Okay. So if you can go to your editor, I wish they had like a key I could switch these for. Right? So back to Kate. We can run Cabal sandbox in it. Okay. That was really exciting there.
Mm-hmm.
It did a whole bunch of nothing, but it will make things easier later. All right. Okay, so now we've got sandbox in it. Next up, we will write some code. We make your data your data folder first. And the reason for this is that source is where your source is located, but data is the name of the parent module that you're going to place this in. Okay. So once you start with this, you'll be able to add your module, data.fptree. This is supposed to be the first line of your file named fptree.hs. And this will also be what other people can reach in your library. Okay? Okay. Now, let's go. I guess probably I won't make that because it's going to be kind of tedious for me to write that all in. But you can see what it would look like. So here, we start out with module, and then after that we're going to add some imports. All right? It moves two at a time. Okay, so for these you need a couple of them. First, I mean, you could write a try on your own, but I just decided to go with one that exists. It's really full-featured. There are like a zillion functions associated with it, so probably it'd save you a lot of time. Mm. Now, the Patricia map is actually pretty simple to see, but the exact reason that you have to include the base map as well escapes me. I mean, they require an A list as one of the type parameters, and I'm not really sure why it has to be that way. It just is. Okay, now the map is pretty.
So can you go back to the previous slide, and so that's FP tree.
Do you need that in the file?
Yes, module data fptree. This goes at the beginning of your fptree.hs. All right. So how are we looking to the viewers? Do we have any questions? Sounds like no. All right. Got so far? All right. Well, then we need to import a couple of things. All right. Much typing going on. All right. I got a text saying apparently she thinks she's on a delay. Maybe I can't hear her. Turned up my sound. I hear nothing. Yeah, it says we have 2 viewers, but no person actually on the call. So make sure you're actually on the call. Okay. Okay, so do we have dependencies so far?
I don't.
Still typing. Okay, cool. That's fine. All right. Wish I could type more. Okay.
Oh, yeah, I'm missing data hash map.
No, I can't hear you at all. Yeah, sorry. You think you're both viewers? Okay, that's good.
What package do you know is list try?
Oh, it's in list tries, LISTTRIES. But we'll get to that. You don't have to install it all yet. That's in the next few slides.
That's what I'm trying to do.
Yeah, getting a little bit ahead. Okay. Well, since you got that far, I think that tells me that I can move on to the next slide safely. Let's see. So we need to create your record data type. So in other words, this is what you're going to be passing around between your functions. It's basically just a wrapper for the parts of your frequent pattern tree. Now, there are tuple data types as well. But in this case, I chose a record data type, so you can call the fields of it histogram and tree. All right. The deriving part at the end will give you a nice, pretty way of showing the content. Yeah. All right. Now, the thing about it is, a histogram and tree are functions like everything else is, and they're all in the main namespace. So you can't use let tree now. It won't make sense because that tree already exists for the whole extent of this file. There's actually been a lot of contention about what exactly to do about that in the Haskell community.
So you mean you can't have variables named what?
Named tree or histogram now.
Tree or histogram. Okay.
Yes, because they exist everywhere.
Oh yeah, because now
they're
functions. Yeah.
So if you call histogram and then your FP tree, you'll get the histogram out of it. Yeah, kind of an oddity, I thought, but I guess that comes along with it. Okay, so now that we have that, this is kind of a side talk here, but you have to see that back in our record data type, we have an FP tree of T. But the thing is, T is not particularly clear. It's not exactly clear what exactly T means here. Because if you look on the left side, we have FP tree T. But on the right side, we don't. It disappeared. And then it shows up inside the record definition. Okay. Now, the reason for this is that we're actually talking about two different namespaces. So getting back to the slide explaining it, you can take a look at this definition here. So on the left, we have type constructors. On the right, we have data constructors. Right? So inner and leaf both count as a tree. But then when you want a list of it, and you'll take it as an argument, you want a list of trees, not a list of inners or a list of leaves. It's just part of the nature of algebraic data types. Okay? So they live mostly in separate worlds. There's actually, I can send you the slides, and there's more to it than this. But this is probably all you have to know. But to see the concept here, your type constructor took an argument, but your data constructors don't. So that argument is what you're going to, what you'll contain. Now in this case we didn't use it, so like it would only make sense to pass around R if eventually we needed it for one of the data constructors.
So what is the point of R? Like what's the point of the argument for the type constructor?
It's like generics in most other languages. So you can send a type to a type constructor and then use it later on in the data constructors. And it would be the same as like an array list of string in Java or something. You could just use string later on inside your generic type without calling it a string. You just call it maybe a capital T is
convention.
Yeah. Okay. So it sounds, the only thing that's really confusing about it is the fact that nearly all of the time the left and right have the same name, but they're actually two different things in different namespaces. Okay. So as a quick recap that I found particularly enlightening, but I don't know, maybe it will help you, is that data is destruct. What type is the type def, if you're familiar with C or C++. Okay, so that's why we also have a type down at the bottom, which is just an alias. All right, now moving on a little, we need to create the first pass for the frequent pattern tree, which consists of finding the probabilities, or I guess relative frequency of each of the components in your data. So each item in your data set, I guess you could say. So the situation here, like if we have a whole bunch of sets that contain A, we're going to find how many of those sets contain A. It's pretty easy to do. So the whole concept is if you move all of those to the beginning, or the beginning of your item set, then it will make your tree a lot smaller. Okay? So this is the functions that I'm using for it. It's from data hash map. I'm not sure if I already imported it. I think I did put that at the beginning. But yours has qualified, I think, and qualified is the way to do it. But I didn't want to write in T dot or whatever at the beginning of all of these. Okay, so the important ones here, we can convert a list of key value pairs into a map, and then we can merge together maps. Okay, simple enough? Are there any light bulbs that just went off?
I'm trying to wrap my head around the syntax because I'm not familiar with that.
Oh, okay, sure. Well, if you look at from list with,
Right.
the first one is it's a combining function. It's really a binary operator. So we're trying to merge together two A's into one A. Okay, and this is used So if you have a lot of tuples that all have the same key, you can merge together the A's associated with them however you want. Like maybe you choose that you always want the first one you find, or always the second. And in this case, we're just adding them. So
you have 3 tuples, and the arrow. How does that evaluate? Is it like
the
right to
arrow,
left? Or is that how?
the arrow here this is just a type definition, so it's not evaluating anything here. All we're doing is we're saying the first argument be AAA, the second argument, to from list with, is the list, and then the third is hash map. So in most other places you might just use a comma, but here they like array, and they like arrows. And the reason for the arrow actually is that you can break these up into multiple functions that each take one argument. Okay? So, and conveniently, we can also add another aggregation function, or reduction, I guess, whichever you want to call it. Oh, to union with.
Hey, how are you guys?
How are you?
So I've been late. I have problems with sleeping these days.
Okay.
I have problems without sleeping.
I know.
I slept in today. So hard.
Oh, do you have anything that will run Haskell?
No, I don't want to like interrupt you guys, so I'll catch up with you later. I'll try to understand what you're doing, so I don't want to like
Well, we have a video on it anyway.
waste your time or something.
Okay. Yeah.
So
All right. Well,
I'll see what tools are you using after you finish.
okay. So far, we've gotten to developing the first, or this is actually sort of a prep for developing the first pass. Okay? So this is just the stuff that you have to keep in mind. So you're developing or are creating a new map, and then you're merging them together. Okay?
Just understand what you're doing here right now is just sort of finding the functions like you're doing C in the header, or is that what it is?
Yeah, you don't have to do this in your file. I'm just trying to load it in your brain.
Okay, gotcha. I was like, wait.
Yeah. Okay? So, now you can start using them. In this case, I'm going to assume that generate root just takes a list of item sets, which seems pretty reasonable. And what it will do is it will create a new FP tree, which is the syntax here of FP tree followed by the braces. And we will set 2 of FP tree's fields as we create it. Okay?
The FP tree is just the struct that, or the data structure we created earlier.
Yes, that's exactly what we just made. And now it's worthwhile to know we put a comma at the end of these expressions in order to delimit them. And you don't have to delimit all of them. So like you could leave out histogram and only define tree. Now that might leave histogram as undefined, which wouldn't be good. But this turns out really useful for the fact that you can update records. Now it's not actually a mutation, it just generates a new copy where everything except the parts that you updated are copies, and the parts you updated are whatever you changed them to. Okay? And the way that you do that is by putting a variable on the left side of the brace instead of a constructor.
Even folder is the variable. Sorry.
No, yeah, we'll get to that in a later pass. You'll find it anyway. So we have to do it. But in this case, we want to make a new one, and so we use the syntax for creating a new record. Okay? Now, a histogram here is generated from our item set list. Okay? Now, we do this first by counting the contents of each of the lines, and then merging together the histograms for each line. Okay? So if we move to, let me see, can I bring a, yeah, there you go. So this, of course, is our main evaluation here. But the meaning of it depends mostly on the meaning of lines hists, which comes from down here, from get histogram on item set list. So basically we're saying here that for every item set in this list, we're going to run get histogram. And that will be, the results of get histogram will be lines hist. And this is just mapping words to 1 and then adding them together. So we're saying every word we found it once. That makes it into a list of tuples, key value pairs, okay? And we will add together their values, one from each one of them.
So that's the plus dot syntax from list with.
Not dot, but just plus.
Just plus.
Or dot is actually function composition.
Oh, I see.
So you're saying that the output of map is going to be the input to from list with.
I see.
This cold chaining, right?
Yeah, you could call it that. I don't know what everybody else calls it, but that works for me.
Because in D3 they call it chaining. They have like calling JavaScript.
Oh, yeah, it's not the same. It's not quite the same. In this case, in JavaScript, for method chaining, the dot indicates that you're getting an attribute of the output of the first function, which is on the left.
On the left, yeah, it's
Yeah.
the opposite way.
Here it's the opposite way.
Yeah.
It looks, and rather than being anything about an attribute, because they're not object-oriented in Haskell, instead we're saying that the output of map will be the last parameter to from list with.
List with.
Yeah, so look here. We
okay.
have this whole concept from map to the end. We'll run this, and then its output will be replaced here and given to and called along with h from list with. So basically the arguments here will be from list with, dot, and then whatever map outputs. Or from list with plus and then whatever map outputs. Okay?
So from with a list with has two parameters. One is how we gonna actually
Process
it, and then the second one is the data structure or the result that you're gonna perform it on.
Mm-hmm. Okay.
Okay,
Kinda
now we
get
can
used to
go.
the syntax.
Yeah, we can get back here to see what it looks like. So this is the first, and this is the merge, which is plus. Okay, and then this is the output of map that we're going to give to from list with, and the result will be a map. Okay.
Which will be passed to the H to be a parameter.
H is just a syntax here. So what we're saying with H is that it's in the H namespace. And the reason that happened, we can go back here to, I don't think you saw this, so. Here we just said that rather than typing out data hash map strict all the time, I instead said that I just want it to be H. So when I say H, I'm actually calling data hash map strict.
Okay. All right.
Yeah, so I'm not passing it to anything. Now, that's one of the reasons that people have gotten in such a huff about trying to use dot in Haskell, because depending on whether or not there are spaces around it, it means different things.
Yeah.
Okay. So here's the crazy thing, though. If you look at this, map actually takes two parameters, and the second parameter here is not defined. You didn't give it anything here. So that's the reason that getHistogram is still a function and not a value. Because there's still one thing left to give to map. That's what you'll give to histogram, to getHistogram. Okay? Does that make sense?
Not quite.
Not quite. Well, look, I mean, yes, but we have on the left side of the dot here, we have a function that takes two parameters. We gave it one, and then we gave it the other. Okay?
Right.
And then we have another function here that needs two parameters. We give it one, we give it nothing else.
Mm-hmm.
And that's why they include all the arrows in the type definitions, because you can stop here and you still have a function. This is just a function that needs one more parameter, and its type will be whatever map needs. And in this case, map needs a list of words. Okay? So that's what getHistogram will be.
And just when you go back to the definition of from list with, it seems like is it a convention that the last part of the definition is the output? Or is like whenever we looked at the from list with?
Oh, hold on. This. The last one is from output. Okay, yes. Okay, you're right. The last one is always the output.
Okay, all right. Cool. That's how you read it. Okay.
I don't even think it's convention. I don't think there's any other way you could do it. Yeah. All right. So there you go. All we did now, we got the histogram of every item in the list, or every item set in that list. Okay. Which gives us a whole list of histograms, and we need a way to merge them together. Okay? I see blank stares. Like really dangerous here.
I think I get it, but when will you fill the other parameter?
We did right here
Yeah,
with get. Yeah, this is the same as like a for loop you might be familiar with in other languages. So what we're saying here is that every item in item set list will be given to get histogram one by one, and we'll take the results of it and make that into a new list. Okay? So we're going to pass one of these item sets to get histogram, and its output will be added to lines hists. And then the next item in this will be given to get histogram, and we go to lines hist, and it just goes, you know, like a pipe from right to left.
Mm.
You end up thinking a lot in pipes, I guess you could say, in functional programming.
So it's mostly like a recursive call.
Yes, map
It
is.
calls itself until.
I mean, yeah, get histogram does not call itself, but map calls get histogram. But map is implemented recursively. Map calls map.
Is how it loops through the.
Yeah, that's how you get through
sets.
that.
So map calls map until what is the termination?
When there's nothing left in the list, which is when there's an empty list at the end.
I have another question. Why map has two parameters? What is the definition of map? So I can reference that.
Well, okay, hold on. Give me a second. Let's see. I guess not everyone will see this, but you can probably, if you were doing this at home or looking at it later on, you could probably find this out in a GHCI terminal. Okay. So I'll bring up. This might actually already be GHCI. Wouldn't that be? Yeah, that's nice. Okay, so if we look at what the type of map is, this is what it is. So it takes a function from A's to B's and a list of A's, and it returns a list of B's. So you can see the concept here. It's pretty easy to derive. It takes in a list of A's, applies that function to everything in the list of A's to get a list of B's.
What after the bracket?
The two colons, or no, the
The
brackets.
square brackets is a list
Yes.
shorthand.
Shorthand for
Shorthand for the list.
This is the input and this is the output.
Mhm.
Okay. Because I'm not familiar with the samples, so Haskell.
Yeah.
So in the actual example you're using, what's the second argument?
Hold on.
The list
B.
of A?
To B or A?
The second argument is
Back to the
A.
list.
Oh, yeah, but I mean,
Yeah.
like whenever you were calling map and you had the word function,
Mm.
so you had the function which was
Yeah.
A to B.
Mhm.
And then
That
you-
was word one or something, remember? From word to word one, or something like that. Hold on.
Oh,
Let me look back at the
there's
slide.
two maps, right? There's one map that does that.
Okay, so we're looking here.
So get histogram.
Oh, and
So
get
there's,
histogram.
there's map, you take the first argument, which is a function.
Yeah.
So where's the list of A's?
Yeah, it doesn't exist there. That's the whole thing. Because it doesn't exist in that definition, get histogram needs one more argument. It needs a list of A's.
And this is the list of B's.
It will return the list of B's when you give it some A's.
So what is, I mean, which parameter is word one, and what is the missing parameter? A or B?
Okay, so the missing parameters are both.
Can you map?
You can't give it B's because B is the output.
Yes.
Okay, but you can give it A's. And the A's are what's missing here. So we could have said, like, this would be some list of words in square brackets, right?
Mhm.
And then that would make this whole thing a value.
For A or B?
We would give it A's, words, and it would return B's, which in this case is a tuple of word one.
Yes.
But I guess the question is, like, whenever you have, well, at least the question I have, whenever you have a function with two parameters
Yes.
and you pass only one parameter, which
Yes.
one of the parameters is gonna actually
It'll go from left to right.
from left to right?
Yes.
So
You can
word
have-
to word is actually a function that would map.
Actually, our question is like, this word to word, is that A or B?
This is A to B. So word
You
here
wanna look
is
at the
A.
definition at the same time.
Oh yeah, okay, that one is, yes. That map doesn't that map doesn't need any more parameters, right?
Yeah, it does.
Which,
Because look in the parentheses. This is only one argument.
oh, you passing a
This is the function
function.
from A, which is word, to B, which is word comma 1.
Yeah, but then map has 2 parameters, right?
Yes, it does, and the second one isn't there.
Which
But why? I mean, it's right that A is /words and then B is word and 1.
Yes. Why would I do that?
Why?
Okay.
What? No. Why? Why is whether there's something missing? Why are you saying there's something missing?
That's just one argument.
Yeah, one of the arguments.
Can we look at the
The type definition?
yeah that definition again of the map?
Sure. Okay. Hold on.
Oh,
Let's do that.
and this is
Uh,
oh,
Now I understand. I'm sorry.
Yeah.
well, no, I mean it's a good thing.
Yeah, same here. So it's left to right. Implicitly, these are the 2 input parameters. This is the output.
This is the output. Yes.
Yeah, I guess not convention, but the rightmost thing in the type definition is the
It's
output.
the output.
And
Yes.
everything else is the input. I was confused.
Yeah. I was.
Yeah.
So my question that still stands is, where does the second argument come from? Like it's missing right now.
I'll show you. I'll show you. Hold on. Let's just start with this as something simple. We'll have, if we do the type of map, you already saw that. But if I do type of map, say +1, this would be things that increment. I'd call this an incrementer. It needs still a list of v's. But you see, that's a function. I just made a new function by giving some parameters, but not all of them, to another function. Okay? So now this function that I made called map +1 adds 1 to everything in the list. Okay? So if I go back and I say, call this, apparently I'm on a candid camera. Okay, haha. It's into everyone then. There, fine, you can see it now. Okay, we have map +1. Let's do let. So we have let adder the map +1. And if I do adder and say 2, 2, 2, 4, 4, 5, something like that, what do you think the results are going to be?
With 4 3s and 2 5s and 6.
There you go. That's exactly what it is. Because I made a new function from the partial application of another function. Just partial application is what they call it. Okay?
And whatever the parameter, the first parameter that you pass to this partial application is going to fill in the first parameter for that.
And look, it's actually a shortcut for something else. So I could say, this is what it really is. So I made a new function. It takes an x, and it will give that x as the second parameter to map. This is what it really means. But we just used a syntax shortcut for that.
What is the last X? Yeah.
It's the parameter. The /x is when we took a parameter to our function, and the x at the end is when we gave that parameter to another function. So
Just redefining the header again, right? Essentially.
yes,
Yes.
this is another adder, and it does the same thing. Okay. Now we don't have to put it at the end if we don't want. We can put it here and then define some items. And now adder will require us, it won't work with a list anymore. Instead, it will require us to come up with what we want to do with it. So maybe in this case, I will say multiply these numbers that are already contained inside it by 2. Does that make sense? More light bulbs?
Yeah, I just don't. Means
So you
yeah.
can just flip the line.
Why?
Yeah. Why? Well, I mean, if you were trying to do it the way of /x, then I think that would be kind of stupid because it only requires you to type more. But a lot of functions in Haskell were designed so that the thing that you're most likely to want to get from the outside is at the end of the function.
Mhm.
So that way, most of the time, you're just defining this. You say that adder is going to be a map of +1 on whatever.
Mhm.
Okay, and that's exactly what I had designed for the application here.
I
So
feel like with this, the reason I got confused was that I guess I didn't look at the actual function name being get histogram.
Mhm.
So really you're like actually making a function. You're not like
Yeah.
actually making a variable.
not a variable.
It
it's a
seems
function.
like there should be some convention for like the naming process for that. Like if you make something and it's supposed to be like a function as opposed to like an actual value.
Well, I know my convention is to place the functions in capital, in camel case,
Mhm.
and the values in underscores.
Yeah.
So I'm not sure if I understand right. If you put x or the variable before them between brackets,
Mhm.
or before whatever you pass, then it's a list. But if you put x after it, then it's a function. Because here,
Okay, hold on. Go ahead.
What I recognized is that X here
Yes.
is before the list and X here is after
Yes.
the operation.
Yes.
Then this is a function and this is an input.
Yeah, actually, that's right. And it comes from type inference. It's the fact that X can be whatever type it needs to be. And map, if you look at the type of map as it existed before we did anything, T map. Okay. Map already decided that it had to be a function if it was first and a list if it was second. So the compiler can infer from that if it comes as the second one, it will have to be a list. It doesn't matter what we name it.
so is it common between all map functions if you use x to determine where you have an input or a function, or do you use something else, or according to the variable that you pass?
No.
So this time you use x to differentiate between these two uses.
Okay, well, yeah, but
You always do use x, or what?
no, not really. I just did that in order to make it clear. Like, look, this is even awkward notation. Like, most of the time when you're defining a function, you would say it's something like this. So, adder of x is map x here. Okay, and you can put x wherever you want and however complicated a function you want it to be on the right side of this equal sign.
Okay, if I say adder a equals, I should say map a. Whatever the variable is on the left here.
Yeah,
I put-
exactly. That's just what it is. If you put a here, then it has to be a in the other one.
Okay.
Yeah. Okay,
Alright.
that's all. Okay, and
And there's no syntactic shortcut to modify the second parameter without explicitly stating.
there is, but it looks kind of weird.
Okay, never mind that. I
Yeah,
don't want to confuse myself.
yeah, it'll just confuse you more.
Okay, good.
It's not really a syntactic shortcut though. It's just another function. That flips the parameters.
I see.
And now you could do a whole series of flips in order to completely drive programmers insane, but I don't think that would be good.
It's called job security.
Yeah. There is a cool one for map though. Flip map is actually probably one of the coolest ones. But we'll get to that later. So let's just go with this, writing the first pass. So do we have any intuition at all what histogram means here?
Histogram.
Yes, in the second line.
I think it's cumulative.
Yes, a cumulative histogram of the whole concept, with the whole item set list. Okay? So, now for...
Mind hist is actually the list of the histograms for each line. Right, well, we just call it lines histogram.
there you go. So lines hist is actually values, not a function. All right?
Need to
Can I figure
go,
out?
yeah.
Yeah.
I'll catch the rest on the Google Hangout.
All right? Good. So now have you written any of this down?
Yeah, I've got that.
Okay.
That part.
Cool. Then,
Wait a minute, did I? No.
okay, so you can write it.
Yes.
Okay. Yeah, but you missed last time, the lecture from last time, which was a lot easier.
Mhm.
I tried to make something a little harder to be challenging, so you just got like dumped into it. Now, there's another one that's actually probably better. If we go with plus in both of these cases, we are counting the total number of times we've ever seen a particular word. But it might be more useful to know the total number of times, or the total number of item sets that it showed up in, rather than how many times it showed up in the set, since it probably doesn't matter if A showed up 45 times in a set, since as the nature of the set, it only can really show up once. So there's no point in adding together the items in the same set. Maybe. I mean, it depends on exactly what it is you're doing. But one of the options here would be for from list width, maybe you'd want max instead of plus. So you have either 0 or 1, but not 2, 3, 4, because it can only show up once per set. Okay? Now, let's go back to the slides. All right. Running our first pass. Present to everyone. Okay. Now, moving on from here.